My name's Gary Lanigan. I'm a research officer at Johnstown Castle, and my main interest is on greenhouse gas emissions and climate change in agriculture. I'm going to be talking about mitigation options for greenhouse gases. So essentially we have about 32% of national emissions comprised from agriculture, mainly made up of methane from enteric fermentation and manure management, and nitrous oxide emissions from fertiliser and urine application to agricultural soils. And really what I'll be talking about today are the two types of strategies that we have. So increasing efficiencies, which tend to reduce emissions per unit product, or what we term emissions intensity. The main methane ones would generally be made up of increasing the genetic merit of the dairy and beef herd, replacing roughage with concentrates, reducing finishing times in beef animals, increasing fertility, and also things like sex semen. And really what they do is they offer about a 20 to 30% increase in terms of greenhouse gas efficiency, okay, or a reduction in emissions per unit product. The same on the nitrogen side of things. By budgeting nitrogen tighter, we can not only increase efficiency, so things like the use of clover, judicious use of slurry, and we can both optimise nutrient fertiliser application on land, but also reduce greenhouse gas emissions. Then on the other hand, we have more interventionist strategies, and they're really aimed at reducing total greenhouse gas emissions. And they really comprise things like adding nitrification inhibitors onto the soils, or feeding them to animals, and also dietary manipulation, and that has quite a big impact. It can reduce both ammonia and nitrous oxide emissions and leached nitrogen emissions by somewhere in the region of 20 to 70%. Now we do have some issues at the moment in that nitrification inhibitors currently coming under a lot of scrutiny, particularly in New Zealand, but into the future, going forward, really the newer strategies that are going to come into play are going to be things like adding biochar to soil to increase soil carbon content and increase nutrient cycling, particularly in tillage soils, the use of biological nitrification inhibition, so that is plants actually producing nitrification inhibitors to prevent N2O, nitrous oxide loss, to the atmosphere, and then also feeding compounds, both in terms of methanogen inhibitors, vaccines, and also nitrification inhibitors directly to animals. So Teagasc are engaged in a wide variety of really new research in these areas moving forward. What we would call the autonomic or the win-win scenario efficiency options tend to be, they're cost neutral or cost beneficial. But we still do have a problem with uptake. So there's a big role, I suppose, to be played for the advisory service there, and also ourselves in imparting the knowledge. Where we have had a success is in changing, for example, spreading date of slurry. So we've moved about 50% of slurry to spring application as opposed to summer application. So we've had that's had a big impact on our ammonia emissions and also some of our soils emissions. But really where we have to work on is things like clover, and also judicious grazing of grasslands. And then on the more interventionist strategies, we've still got a fair bit of research to be done. So nitrification inhibitors, we had a lot of studies on. That has scaled back a little bit. It's incredibly effective, so there's issues about getting it into the codex, particularly the Chinese codex, but moving forward we're looking at manipulating the rumen, particularly the rumen in young animals. Also changing the greenhouse gas inventories to make it more flexible so that mitigation options can actually be counted, so that farmers, or the agricultural sector should I say, can gain the benefit of any mitigation options that we research, because if we can't actually count them towards national targets, then you wonder why you're doing it in the first place. So that's a big area of research, and we're investing several million actually in refining the inventories, looking at soil carbon, and again soil carbon to count towards offsetting greenhouse gas emissions, and then ultimately moving forward we'll be also looking at the impacts of climate change. So what are the impacts of climate change on mitigation and on agricultural production? And we've got a new fairly large core funded research with 4 Walsh Fellows that will be starting next year now, looking at climate change and weather volatility impacts. I suppose the easiest things are making sure that you spread your slurry early, or when it's not particularly hot or not too windy. If you can put in clover and you can manage your sward, all the better. If you can improve as much as possible the genetic merit of your herd, they're not always that easy, but they will be some of the win-win scenarios for the livestock sector. In terms of the tillage sector, really optimising pesticide and herbicide application to make sure you're maximising your yields. Make sure that you've got good ground preparation. Make sure you optimise your fertilisation to match growth stages, crop production, and they're really the main sort of what we call win-win scenarios, really. In terms of then what we're talking about, we have a paradox really. So in 2020 we have a food harvest 2020 targets to, of course, up dairy production by 50%, up beef value and up the value of the tillage sector. But we also have a set of 2020 targets to reduce greenhouse gas emissions by 20%. So really, there's a little bit of tension between those two targets. So what we're saying is as a sector, we won't be able to reduce by 20%, but what we can do is maximise emissions per unit product and maximise the efficiency of the sector going forward. And then into the future, as research becomes more complete, maybe start to tackle the absolute emissions. And particularly again in terms of carbon sequestration, if we can gain the benefit of the carbon that's being sequestered by grassland into the soil and let that offset emissions, and also maximise and optimise forestry production, then they can really go quite a long way probably to helping the sector's emission profiles.